In this video, we will solve a system of equations in two variables by method of substitution, and then after we will also do another method called the method of elimination. So whichever method you use for systems of equations in two variables depends on the way the equations present themselves, okay? So these two equations here can be solved by method of substitution. A shorter method could be method of elimination, but if you know how to use both methods, then you can always pick and choose which method you want to use. So simultaneous equations, which are also called systems of equations in two variables, they are called simultaneous equations because we solve for the two variables at the same time. So these two equations could have possibly been developed from a real-world problem that could be modeled using these systems of equations. So to solve such an equation, to stay organized, you want to label the equation. So this is just a label. Let's call this equation 1 and equation 2. We can call it equation A or equation B. It's just to stay organized so that when we are working with the first equation, we know that we're using the first one. When we're working with the second one, we know we're using the second one. So method of substitution. So to isolate a variable from any of these equations requires careful observation. Now I observed that in the first equation, the coefficient of y is 1. This makes equation 1 a target for isolating the variable y. It will be easy to isolate this variable y from equation 1 than to isolate the variable y from equation 2, or isolating the variable x from equation 2. So the coefficient of the variable x in equation 1 is 2. That makes it difficult to isolate the variable x. But it could be isolated, but just makes it difficult. So this variable of 1, you want to go for the variable that has a coefficient of 1 to isolate it. Okay, when you identify a variable that has a coefficient of 1, isolate that variable. So we will isolate y from equation 1. So equation 1 says 2x plus y equals 5. We can write this as y plus 2x equals 5. It is the same thing. Addition is commutative. If we say 2x plus y is the same as y plus 2x. So now we subtract 2x from each side to isolate y. So that is how we isolate y. When we subtract 2x on this side, then it disappears because 2x minus 2x is 0, and now we just have y is equal to 5 minus 2x. Okay, so we have isolated y. This is a thing that is called isolating y because y, we have rewritten the equation so that y is on one side by itself. Okay, now that moves us to step 2. Step 2 now is the substitution. That is where the method gets its name. We will substitute y equals 5 minus 2x in equation 2. Okay, so we cannot substitute in the same equation that we isolated y from. We now substitute in the other equation, which is equation 2. So we continue over here. We're substituting y equals 5 minus 2x in equation 2. So equation 2 says from equation 2, so from 2, when we circle it, we mean the equation 2. So from equation 2, 5x minus 3y equals 7. So we are replacing y with 5 minus 2x. So this, watch out, this y will be replaced. So we rewrite equation 2 as, this means that equation 2 becomes 5x minus 3. Now instead of writing y, we now write 5 minus 2x in the place of y, and then we continue the equation to say it is equal to 7. Now we have a new equation in one variable. The only variable in this equation now is x. We will go ahead and solve this emerging equation. Okay, so a new equation emerges. So the first step to solve this equation is to distribute this negative 3 into this parenthesis. Remember, Penda says always dissolve parentheses first. Okay, that said, we keep this 5x to sit right here as 5x, and now we have negative 3 times 5. okay? And we also have negative 3 times negative 2x, okay, equals 7. This is called the distributive property. This property right here that has dissolved this first parenthesis is the distributive property. So let's go ahead and multiply. So the 5x sits here. Negative 3 times 5 is negative 15. Negative 3 times negative 2x is positive 6x. And then that equals 7. The next thing to do is to collect like terms together. Okay? Collect like terms. Now looking at this equation, what are the things that are called like terms? They have something in common. Now this positive 6 here has something in common with this positive 5x here. So positive 6x and positive 5x have something in common. We will add them together. So when we add them together, 5 plus 6 is 11, so 5x plus 6x is 11x. So now we have 11x minus 15. Okay, so 15 doesn't have the x, it is going to stay as negative 15. That equals 7. Okay, now the next thing to do is to isolate x. To isolate x means this negative 15, we have to get rid of that negative 15. And to do that, we will add 15 on each side. So plus 15 here and plus 15 on this side. So that said, this 11x comes down here as 11x to the next step. Okay, so this means that we have 11x on this. And now negative 15 plus 15 is 0. So that is why we're adding 15 on both sides, so we can isolate the x term to stay on this side by itself. And that equals 7 plus 15 is 22. Now we divide each side by 11. Okay, 11x equals 22. We divide each side by 11 to get the value for x. All right? And so that leaves us 11 divided by 11 is 1. So we have 1x equals 22 divided by 11 is 2. So 1x equals 2 is just the same as x equals 2. So now we have the value for x. The next step is to get the value for y. All right, one easy way to get y is to use the form that y was isolated. So we know that y was isolated to be 5 minus 2x. Okay, so now to get the value for y, we replace x with 2. So this means that y is equal to 5 minus 2. Remember, x was 2, so we are replacing x here with 2. Okay, we found the value for x to be 2. So this is the thing with substitution method. If you get a wrong value for x, you will get a wrong value for y because you will plug in the wrong number. Okay, so y equals 5. Now this number is negative 2. Don't get confused and say this is a minus sign sitting here by itself. No, this is a negative 2 that will multiply this 2 in parentheses. So negative 2 times 2 is negative 4. So y equals 5 minus 4, and y equals 1. Okay, now we have our values for x and y. Our x is 2 and our y is 1. Okay, you can test to see. Okay, to avoid the situation that you could have made a mistake to get the wrong values, you can know that your values are wrong by testing these two values in equation 1 or equation 2. Let us investigate if those two values are correct. Remember, equation 1 says 2 times x plus y should be equal to 5. So if x is 2, then let's substitute 2 times 2 plus 1. Is that equal to 5? Let's find out. 2 times 2 is 4. 4 plus 1 is 5. So 5 is equal to 5. Is satisfied. The two values satisfy equation 1. But remember, don't quickly conclude. They need to also satisfy equation 2 so that they are the actual values, they are the true values. Okay, for these two values for this value of x and value of y to be the true values, they need to satisfy the two equations. So let's try the second equation. The second equation says 5x minus 3y equals 7. So x is 2. So we go 5 replace x with 2, minus 3 replace y with 1. What is that? equal to 7. Let us simplify to find out. Okay, so 5 times 2 is 10. Negative 3 times 1 is negative 3. Does that equal 7? 10 minus 3 is 7. So 7 equals 7. So we conclude those two values satisfy the two equations. And so we can conclude that x equals 2 and y equals 1 are the true values for this equation. Okay? So now let's look at the next method is method of elimination.